Okay, so this is the final video for this chapter where we're going to focus on amide. So amide are like esters, are abundant in all living organisms. Protein, nucleic acid, and many pharmaceutical agents has amide as a functioning group. So the reason for this abundance of amide that they are stable in aqueous solutions found in the living organisms. Amides are the least reactive of common acid derivative and undergo relatively few nucleophilic acid substitution reaction. So amide has the general formula of CnH2nCO(NH2). So the naming of amide are dependent on the classification of amide itself. So the general naming of N with amide. So following our guideline of naming different classes of amide. So for primary amine, so for primary amide will end with the formula CONH2. So if you have 2C, we call it as ethanamide. If you have 3C, we call it as propanamide. 4C is butanamide, and the benzene ring of CONH2 is benzamide. For a secondary and tertiary amide, so secondary amide is based on how many carbons surrounding this nitrogen. Since this nitrogen is surrounded by 2C, therefore it's called as a secondary amide. And if this nitrogen is surrounded by 3C, so this one is called as a tertiary amide. So C in the CONH2 as the parent chain, while the alkyl attached to the nitrogen as substituent named accordingly, and the number N is given for alkyl that is attached to the nitrogen. So for example, if you have the parent chain is CONH2, so this will become the parent chain. So 3C is propanamide with 1 methyl, so N-methyl propanamide. So next example is if you have 4 carbon CONH, so this one is butanamide. So if you have cyclopropyl surrounding it, so this is called as N-cyclopropyl butanamide. And if you have a benzene surrounded by the NH, so this is what we call as benzamide. So you have a phenyl group surrounding in here, therefore N-phenyl benzamide. As for tertiary amide, it is also named similarly. So this is the parent chain with the 2C, so it's calling as ethanamide. Since you have 2 methyl surrounding it, therefore we call it as N-dimethyl ethanamide. For the next example, we have 3C. 3C is called as propanamide. So if you have methyl, if you have ethyl, you still follow according to the IUPAC numbering. So ethyl first, then methyl. So therefore N-ethyl propanamide. And finally, if you have this is a benzamide. Okay, so this is a phenyl, this is a methyl. So N-methyl, N-phenyl benzamide. So this is generally how we name this amide. So as observed in the example above, isomer of amide usually involved in chain isomerism, as the alkyl can be attached to the parent chain or as a substituent in N. So if you have 4 carbon, actually it's C4H9, yeah? And then this one is C5H11. Okay, so if C4H9NO, so you have butanamide, N-methyl propanamide, and N-dimethyl ethanamide. And then if you have 5C, then there are going to be more variations as you can see in here. Okay, so once you name the isomer, they can be classified accordingly to they can have isomer according to different classifications, as you can see from all the examples in here. So amide can be prepared by using carboxylic acid and also acyl chloride. Chart below show how effectively different classes of amide can be synthesized using carboxylic acid and acyl chloride with ammonia or different classes of amine. So generally, primary amide can be synthesized by using concentrated ammonia inhibited with ethanol acid, or you can react with acyl chloride. So of course, as we mentioned just now, acyl chloride is always the best way to synthesize different classes of amide. Okay, so if you want to synthesize primary amide, there are the 2 ways. So if you want to synthesize a secondary amide, so you use a primary amine. If you want to synthesize a tertiary amide, you use a secondary amine. So hopefully this chart should be able to help you to understand better. So because amide are the most stable acid derivative, they do not easily converted to other derivatives by nucleophilic acid substitution. So from a synthesis standpoint, their most important reaction is the reduction to amine, which is one of the best methods to synthesize amine at different classes. So amide are hydrolyzed by strong acid and strong bases under reflux. So if you react with dilute sulfuric acid or dilute hydrochloric acid, so the CONH2 will be broken. Then you have H and OH. Yeah? So the H will be attached to the nitrogen to form ammonia, while the OH should be attached to the CO to form carboxylic acid. So you have ammonia plus carboxylic acid, but ammonia is base. It will further react with the acid to form ammonium salt. However, if it is alkaline hydrolysis, so similarly you form here, here is OH. So you form carboxylic acid and also ammonia. However, because carboxylic acid is acidic, so it will further react with the sodium hydroxide to form a carboxylate salt plus ammonia as a side product. So the reduction of the amide can be used by using a strong reducing agent such as LiLH4 followed by H3O plus under reflux. And finally, we have dehydration of the amide. So we are going to have a look one by one for all these reactions. So hydrolysis of amide undergoes to yield to carboxylic acid plus ammonia or amine on their heating in either aqueous acid or basis aqueous solution. The conditions required for amide hydrolysis are more severe than those for acyl chloride or ester, but the mechanisms are similar. So if you are undergoing acidic hydrolysis, you form carboxylic acid and ammonium ions. If you are alkaline hydrolysis, you form carboxylate salt plus ammonia. If acidic hydrolysis of secondary amide, you still form carboxylic acid plus a primary ammonium salt. If you react with secondary amide with ammonia hydrolysis, you form carboxylate ions and also primary amine. Hydrolysis of a tertiary amide will give also a carboxylic acid and a secondary ammonium salt. And tertiary alkaline hydrolysis of tertiary amide will give carboxylate ion plus a secondary amine in here. So the reactions in here you must clearly divide into each of the respective substance involved. So here are a few examples of the reactions of hydrolysis with acidic hydrolysis. So you can see here, this is the results given off by the primary amide. While these are also the result given off by primary and secondary amide. So you form carboxylic acid plus ammonium salt, and this is the acidic hydrolysis of tertiary amide. You form carboxylic acid plus secondary ammonium salt. While this is the examples for alkaline hydrolysis, if you react with sodium hydroxide, you form sodium benzoate and also ammonia. Alkaline hydrolysis of this secondary amine will give carboxylate salt and also primary amine, and hydrolysis of tertiary amine will give carboxylate ion and also secondary amine salt in here. So when amine is treated with strong reducing agents such as LiLH4 followed by H2O+, it can be reduced to form amine. So note from the reaction, carbonyl group is removed by replacing the hydrogen, therefore reduced. So primary amide will be reduced to primary amine, secondary amide will be reduced to secondary amine, and tertiary amide will be reduced to tertiary amine. So these are the examples for the reductions of each of the amine. So as you can see in here, basically you just change the C double bond O into CH2. So in here you can also see C double bond O becomes CH2, C double bond O becomes CH2. So you can see each of them has been reduced to their respective amine. So as described just now, the similar classes of amide will form similar classes of amine. So strong dehydrating agent can remove elements of water from primary amide. So this only works for primary amide to give nitrile. So dehydration of amide is one of the most common methods to synthesis nitrile. So phosphorus pentoxide is a traditional reagent for this dehydration. So in here you can see somehow in some way you form a nitrile by eliminating water in here. So note that this reaction is only applicable for primary amide since water can be removed according to informed nitrile. So as mentioned previously in chapter 4 and chapter 6, since you form alkane nitrile, then it can be converted to carboxylic acid and also amine using suitable reagent. So if you use acidic or alkaline hydrolysis, you form carboxylic acid and carboxylate salt respectively. And finally, if you reduce by using a reducing agent, you form an amine. So here are the examples of the reactions, each of them respectively. So you can see when butan amide, when you dehydrate, you form butyl nitrile. So butyl nitrile undergoes acidic hydrolysis to form butanoic acid. When reduced, you form butyl amine. And then if you react with 2-methyl butan amide, so you form 2-methyl butyl nitrile. So alkaline hydrolysis will give the carboxylate salt, and also reduction by using hydrogen emitter will also give NH2. Okay. Okay, so with this we finished chapter 7, so let's see you in the next chapter on chapter 8. Thank you.